Compounds can be separated into two major categories: covalent compounds and ionic compounds. Covalent compounds have distinct molecules with a precise number of atoms of two or more elements arranged in a precise three-dimensional structure. Ionic compounds consist of a three-dimensional lattice of negatively charged ions called anions and positively charged ions called cations. Anions and cations can either be single atoms, such as Na+ or Cl-, or polyatomic, such as NH4+ or NO3-. Each covalent compound has a molecular formula and an empirical formula. The molecular formula gives the precise composition of a molecule. For example, hydrogen peroxide has a molecular formula of H2O2. The empirical formula is the simplest way of expressing the ratio of atoms within the compound. Therefore, the empirical formula of hydrogen peroxide is merely HO. In many molecules, for example H2O, the molecular and empirical formulae are one and the same. In the case of ionic compounds, where we only have a lattice of cations and anions, no distinct molecules exist. As there are no distinct molecules, the only meaningful formula is the empirical formula. Nomenclature is the systematic naming of chemical compounds. Whether a compound is covalent or ionic, nomenclature in French is done from right to left, as opposed to left to right in English. NaCl is sodium chloride in English, but is chlorure de sodium in French. CO and CO2 are carbon monoxide and carbon dioxide in English, but it is monoxyde de carbone and dioxyde de carbone in French. Sometimes the phase of the molecule affects the name of a compound. In its pure form, HCl is a gas called hydrogen chloride, but once dissolved in water, it becomes hydrochloric acid. Finally, nomenclature often has a systematic approach that allows one to figure out a chemical formula if a point of reference is provided. Oxyacids are one such example, where the number of oxygen atoms can vary from compound to compound. The addition of an oxygen atom has a well-defined effect on the name of the compound. Also, as these are acids, protons may be lost, and again, a systematic effect on the name is seen.